And this meeting is being recorded so that you guys can also utilize this for any content, but that's what we'll be doing as well, as posting this on our website and everything. Welcome, everybody. See, we have some people joining us. Welcome, everyone. We're going to go ahead and get started in a few minutes. Wait for others to join the group. Welcome, everybody who's coming in. It's good to see you all here on this coffee break. I, for one, mine is going to be a water break today because I've already admittedly had enough caffeine for today. So coffee, tea, water, whatever you have. Well, we're just going to go ahead and get started in just a couple of minutes here. We'll give everyone time to join, and we'll go ahead and get started with this second installment of our coffee break, water, tea break series. Today focused on recycling robots. Okay, well, it is 1 minute past, so we're going to go ahead and get it started. Welcome, everybody, to the second installment of our coffee break tech series. As most of you know, WISR is an organization built for women in the solid waste and recycling industry, and to promote leadership of women in the industry and help diversify the leadership in the industry. And when we first started WISR, we polled our members and every woman we could find in the industry and asked, what would you want or need in a women's organization? And what we heard became our 3 values here at WISR, which is networking, So an opportunity to network and build connections and a community, and leadership development and emotional skills development, and then what this coffee break series is about, technical skills and kind of a safe space to learn about the 101 of recycling and this industry and the nuts and bolts of this industry. So our last one, if you're able to join us, was on Trucks 101, and we heard from Ashley Porter about all the different types of trucks and what parts, major parts make up a truck. And it was really informative, and we got excellent feedback. And today we're going to talk about recycling robots. And this is a something that's growing rapidly within our industry, the application of AI and artificial intelligence and robotics. It's being adapted quickly because it's cost effective, and it gives great data about what's in the material stream. And so we thought that our audience and our community at WISR would really benefit from learning about something that's really cutting edge and is being developed rapidly. And when you're able to learn these technical skills, and you can bring them to the table and you're within your organization and really start becoming the go-to on topics like that we cover here. And so with that, I'd say always develop a connection with our panelists, our speakers. I know they're on LinkedIn. I'm sure that they'll share their information with you. So always look to each other to develop that community and network. One thing that we did in the last session, because we always, like we said, networking is a really important part of WISR, is that we like to do a little icebreaker so everybody gets in the chat. So if everybody can open up their chat function, we want to know who uses robots on a daily basis, who utilizes robots within their homes, robotic vacuums, robotic toys. There's so many robotic, parking in your car. Get in the chat here, and I'm going to stop sharing my screen so that we can pull up the panel here and the chat, and tell us who uses robotics. I know I do. I don't have a Roomba. I have a much cheaper version. It's the iBob or something like that, but I utilize it. Oh yeah, Roomba is a lifesaver. Roomba, Alexa, yep. We were talking about that before. Alexa's definitely robotic. Dishwashers, Roomba, car, yes. It's being applied in every part of our life, and it's even being applied behind the scenes in our recycling infrastructure. And that's what we're going to learn about today. So Kim, yep, Google Home, okay, same thing as Alexa. Turn on the lights, close the garage door. I know we use a Ring, so that's another form as well. Car lane control, yeah, that's always a good one, yeah. Okay, well, thank you for listening to my introduction. And now I'm going to, on WISR, and now I'm going to introduce our panelists today, some awesome women in solid waste and recycling. First, and we're doing co-presenting too, which I think is really great because it's like co-leadership and collaboration. So I love that. So let me introduce Moana. Moana Sato joined AMP Robotics in 2017 after reaching out to Matanya Horowitz with an ambitious goal that aligned with the company's mission: radically increase recovery rates and fundamentally change the economics of the waste industry. Her work within the company contributed to the deployment of 100+ robots, identification of materials never being sorted by recycling facilities, and AMP's ability to partner with major brands as expectations rise for extended producer responsibility schemes. She currently serves as a sales accountant and operations manager, so wearing multiple hats there. I love to see the merging of sales and operations, supporting the ground up creation of sales process, organization of enablement tools, and interdepartmental coordination. She also coordinates and manages AMP's Japanese accounts and clientele, and has her bachelor's degree in mechanical engineering from University of Colorado, Denver. And Amanda is a senior director of product for AMP Robotics, responsible for technical product development for the company's artificial intelligence platform, robotic sorting systems, and software capabilities. She has more than 10 years of experience in product development at General Electric and Amazon, with a focus on hardware and software products used in industrial processes. And Amanda has a master's degree in management science and engineering from Stanford, and a bachelor's degree in aerospace engineering from the Georgia Institute of Technology. So I want to welcome Amanda and Moana, and just point out that that this is just an incredible representation of the reaches of this industry, and how new and different people with different backgrounds in technology are starting to enter this industry and influence it in such a positive way. So without further ado, I'm going to hand it over to Moana and Amanda to teach us about robots. I'm excited.
Thanks so much, Rachel. Amanda here. So nice to meet you all today. We are thrilled to be here, and we hope that you find something super useful for from our presentation. So let's start today with a little context setting on the magnitude of the recycling industry. Globally, more than 200 billion, yep, that's with a B, worth of recycling materials go unrecovered annually. That's a lot of stuff going to landfills. So we stepped back and we asked why this was happening. And like most things, it comes down to the economics and the efficiency of being able to identify and sort these materials: paper, plastics, metals, and other recyclables. It's just a major challenge for material recovery in general. So in recent years, the waste industry has also faced stricter international quality standards for contamination-free imports of material destined for recycling. So that has really left this industry in search of cost-effective alternatives to meet these requirements. Next slide, please. Thank you. So material recovery facilities, or MRFs, are tackling these challenges by really taking a look at the way that they work and saying, where can we make a change to go after this better? So data and automation are really coming in to drive efficiency and decision-making as well. In the United States, there are many thousands of municipal recycling programs nationwide that are collecting all of the material generated by millions of people. That's just the US, right? It's even bigger when you think globally. And these facilities, these MRFs, become these centralized material processing hubs. So a major challenge that these MRFs have is just the high cost when attempting to sort out commodities. And these commodities continue to evolve with complex form factors and different material compositions. So today's MRFs require a tremendous amount of manual labor. And if you've been reading any of the articles I've been reading, manual labor is really, really difficult to consistently get. There's also high residue loss, meaning these are items that aren't recovered and they're going to landfill. And continuous challenges to make sure that the commodity bales that are created are of high quality or purity. That has twofold effect. It can go to the folks who want to buy those commodities, but it also can help the MRFs demand a higher revenue for that bale of the commodity. So basically, the value of scrap commodities is just eroded by the high cost of sorting. So next slide, please. And that's where we've come in. So at AMP, we've made it our mission to develop cutting-edge technology to drive down the cost of sortation while providing the tools necessary to improve operational efficiency and elevate the recovery rates of these high-value commodities. So basically, how can we make it faster and cheaper to go get the good stuff out of the waste stream? And it's all made possible by using the data-driven approaches to automation within the key elements of the facilities. So I want to give you a little background on AMP. We were founded in 2014 by Matanya Horowitz, PhD. He is still our fearless leader, our founder, and our CEO. Our team is based in Colorado, and our technology is made in the USA. We now have close to 200 employees. We've grown really quickly over the past year with 3 facilities, and we continue to scale. Our installed base is currently over 160 systems, 3 continents internationally, and more than 25 states domestically. And within our installed base, we're happy to say that we have a deep rapport with our customers, spanning across various applications, single stream, MSW, organics, e-scrap, and C&D, or construction and demolition. We as a company are backed by top global investment firms. That's always nice to be able to say. And these firms have backed other technology pioneers. You might have heard of a couple of them, things like Google, Facebook, Tesla, SpaceX, some big names. We've fortunately raised more than 70 million to accelerate the innovation of our cost-effective sortation technology. And complementing this investment capital, we also receive innovation funding through organizations like the Department of Energy. They help us push advanced technology boundaries with great partners such as Idaho National Labs. So in addition to our flagship Cortex system, which we're going to go through in a minute, we're expanding new infrastructure solutions with the pilot of an AMP designed and operated secondary sortation facility. There's just so much waste out there that we need more processing of it. So you combine all of these factors, and AMP has emerged as a technology, innovation, and thought leader in the waste recovery industry. So very proud to be here. Next slide, please. Okay, so back to all of those sortation problems that we were talking about for MRFs: high cost, low efficiency. With AI and robotics technology, we've developed a high-speed, intelligent robotic sorting system. It's got 3 main components, and you can think about it kind of like a human body. You've got a brain, you've got eyes, and you've got arms. So we'll start with the eyes. The system's computer vision, the eyes, it identifies the material as it's coming down a conveyor belt to be picked and sorted, just like a human would. Then the brain comes in, that's our AI platform, and it converts these images into data. It categorizes it, and it says, hey, we know what this is, we're calling it, whatever the material is. The AI then guides the robot, the arms, to pick and place that material to be recycled. And all of this is happening way faster than humans can do it. Typically 80 picks per minute, and in some applications, we can achieve 120 picks per minute. Typically, a human sorter, when you get to a steady state, is about 40 picks per minute. The other great thing about AI and robots is they don't need breaks. They can keep going, and they have consistent precision and extremely high accuracy. Next slide, please. So outlined in a different way, we have 4 core parts of our technology suite. So AMP Neuron, that's our industry-leading networked brain system that characterizes materials. AMP Cortex, that's our high-speed AI-guided intelligent robotic system. AMP Vision and Clarity, so we can take the eyes and the brain piece and have it stand alone as a material characterization system that gives you real-time facility information. And then we can present all of that information in our web-based portal called Clarity that can give you data, reports, alerts, and different insights on what's going on at your facility. And last but not least, we have our secondary sortation facilities, fully automated, built using our next generation technology. But all of the suite of these products are focused on one thing: shifting the economics of recycling. And since all of the different sortation types really rely on AMP Neuron, that's the center at all of it, we are now going to take a look into more about that brain piece. Over to you, Moana. I think you are still on mute.
Am I? All right, perfect. Let me try to get this playing. So a little bit about our core technology, the AI, is that it does identify materials just like humans do. So, just like a hand sorter does, they look at the shine of the material, the brands, the colors, the texture of the items they see. What makes artificial intelligence so special is that it's able to take some of these examples that AMP is able to teach the AIs and continuously improve upon it, as well as use all of our install base to help us make the improvements better. Oh my goodness. But, we don't have to teach it every single material and every single dimension that you would see something in. As long as we're able to give it all the examples possible, it's able to make its own understandings using some of the features that we taught it. Oh, this is a little example of how our AI is able to see and classify material. And so not only does it see materials as it stands, but it's also able to see the outlines of things, point out how confident it is with the materials that it's seeing, and also even when they're stacked on top of each other, it's able to find and identify where the centroid of that item is so that our robots that come after the AI is able to accurately remove those items. So material characterization, we are able to do down to the brand of identification. What this does is, you might say, you can't identify every single brand in the world. It's going to slow down the process of sorting materials that we need as commodities. But actually, being able to separate down to the brand not only opens up a whole different type of sortation that recycling has never seen, but it's also able to bring into the market customers that have never thought to have to buy recycling. This is driven by EPRs and different kind of consumer product packaging makers where they're supposed to use recycled content. And now they need to start looking for recycled content. Where do they get it? They can use AMP technology to start removing those items just as they need it. Good example of this is you can see on the right side, like the Tide Pod green PET bottle, something like that. If they needed to start making that container out of recycled content, they need to start collecting those containers. They can't have purple ones. They can't have blue ones. They need that exact green shade. And because our technology works with human features, we're able to pick out exactly that color, start creating a source, and start selling it to a whole new brand of customers. What this does is it changes the way that a recycling facility can operate. Just as much as there's constantly a new flow of materials coming in, there's going to be a constant new flow of new customers coming in to buy materials. We're not just using data to train our AIs, we're using data to give some of these producers the information they need to know where to go to get what they need, where to go to figure out who's recycling what, who's buying what, and changes kind of the structure of the aftermarket in general. Oh, this is a good example of how we worked with a brand back in the day, back when I was just a data analyst at AMP. We were able to look not just at the material that we were seeing, but start sorting out Keurig cups. What Keurig really wanted to do was they've been historically known as the bad guys in the industry that were unrecyclable. All the sustainable people hated them. But what we were able to do is start identifying those pods. As you can see on the left side, it's called plastic pee-pee pods. And by identifying those as a specific thing, we were able to then start having our robots removing them. And then they were able to change the containers to be a plastic that is recyclable. And so instead of virtually saying that nobody wants them and they're trash, we were able to then switch over to help them become actually recyclable and start recovering it from that residue line that Amanda was talking about. So the pods that used to be made out of polystyrene are now shifted with the brand to be a polypropylene, and it has become something that is a commodity that people desire and want to know about. This is a little bit about the secondary automated facilities that Amanda was mentioning. And so because we are as a country so bad at recycling and sorting, and we also have so much trash that there is always a huge volume of material that can still be recycled going in to residue lines, going into landfills, and never seeing the light of a recycling plant. And so what we're able to do with our technology is to start looking at the stream that used to be identified as trash and start looking for pieces of recyclable golds. So that could be something like metals, could be something like paper, but it could in the future be something like a Tide Pod container or a specific brand's cup because they make it out of a special material, or even a Keurig cup. And so slowly using the flexibility of the artificial intelligence, we're hoping to change the foundation of what we identify as recyclable and hopefully improve the amount of things that we're reusing and decrease the amount of things that we're permanently throwing away. Thank you.
Yeah, so thank you so much. That's the end of our presentation. We wanted to leave plenty of time for your questions. So I don't know, Rachel, how do we want to do this? Is it all through the chat?
Well, we didn't get any questions in the chat or in the Q&A. So you know, I'll put it out to the group now. If you have any questions or want to hear more about how the technology is being applied. Nicole, thank you. She said very cool presentation. Is anybody currently, you know, utilizing robotics technology at their MRF or locally where they live? Maybe you work for a government or jurisdiction. Or is anybody interested in utilizing robotics? Well, we don't have any questions from the group, so that's okay. Amanda and Moana, maybe. Okay, Suzanne, how does the robot handle picking different materials?
Yeah, that's a great question, Suzanne. Thanks so much. So we have a gripper that we've done a lot of testing with the gripper over the last few years, and we figured out there's the gripper assembly and then there's the gripper itself. If you take a look at the robot, that's the little blue part. So a lot of times when people talk about the gripper, they're just talking about that little blue part. But when we talk about the gripper, we're talking about the whole assembly and how it works together. So we've done a lot of testing to make sure that we've figured out the whole assembly and what's the right airflow that you need, what's the right size on that little blue gripper cup to get the best grip possible. So in doing this, what we're really doing is trying to optimize for being able to pick all materials that are of a certain size. And of course, you know, there's limitations if you're talking about a big C&D 2x4, that's not going to be picked up with an air suction gripper, right? But if everything's kind of, you know, that small size, small, lightweight sort of item, that's what our gripper is really focusing on. And so we're really trying to make it so that you don't need different grippers for different material types as much as possible. But Mona, you've dealt with a bunch of customer installs. Anything that you want to add to that?
Well, I wonder if it's the robot handling picking different materials as in physically, or if we're doing it identifying, because we do have the neural network itself identifies 34 different materials today. The list is growing really quickly with Amanda's help in our company, but and because it can identify 34 different categories, it's able to separate as much as 34 items at the same time. And so really the only thing that's holding it back is how many containers can it throw into? How quickly do you want the robot to be moving? Because it can throw as crazy as possible, but then if you need it to get into a little tiny hole, you know, we need a little bit more precision and a little time to move it. But the gripper itself, we've seen it start handling materials that are really big, wrinkly, and crushed like natural HDPE bottles. But at the same time, it handles material like UBCs that are tiny and has those little wrinkles, and even C&Ds. So we've seen a lot of success across the board pretty broadly, and it's only getting better as we work on it.
Thanks, Mona.
Yeah.
Yeah, amazing technology. Several clients that are using it. Awesome. We love hearing that. Have we seen any data on the difference or increase in what's been recovered at these facilities since the installation of the robots? Yes, absolutely. We've got some case studies for it as well. But Moana, since you're much closer to some customers, any case studies that come to mind that you want to highlight here?
You know, I do think that it does come down to that staffing issue that we're seeing. A lot of our customers actually have downtime just because they can't have staff there to sort the material. And with all the expectations of quality at the end of the line, they really can't just keep running just because they want to. Material keeps coming in, but if they don't have these sorters to do it, they have to shut down the whole facility. Our robots have made it possible for them to continuously run. We have facilities that run 24 hours a day now. And so just in general, if you're going from 2 shifts to 3 shifts, you see a huge increase in recovery rates. And I have heard actually from people that buy the material that the bales that our robots make is almost a little bit eerie because it's so specific. They're like, I bought a tubs and lids and it is all literally tubs and lids. Like I've never seen this, where a human does a little bit of that improvising. And so it kind of shows you like how serious a robot is about its job, but at the same time, you know, how flexible it could be depending on what we decide to teach it.
We have a few questions coming up in the Q&A as well. Nishat asked, what is the pick rate and accuracy on the robots? And I know Nishat is working, I just know personally, she's working on developing a plastics resin plant. So she's, I'm sure, interested in what the accuracy and the pick rate are for facilities like hers.
Yeah, sure. So pick rate, it's my favorite answer. It depends, right? So much of it depends on your belt speed, how much burden depth is on your belt. But our typical robot performance for a single unit, we also have a tandem unit configuration, is about 80 picks per minute. But we also have just released what we call the dual grip. So it's 2 suction cups on one grip assembly, and we can achieve 120 picks per minute for that. So your pick rate really depends on the configuration that we would want to set up specifically for your plant to get the most out of it. Accuracy is really dependent on what Moana was talking about with our ability to identify the material. So I always like to say, see it, sort it, report it. That's kind of the summary of what we do. So as long as we're able with high confidence to be able to tell what the item on the belt is, and so much of that depends on your specific belt, then we can go after it and get it into the bunker. So that's what it's all about at the end of the day, right? Is getting it into the bunker for you.
Get it in correct.
Correct.
Let's jump to the chat here. Desiree asked, I'm curious about what a MRF does if the scrap price of the sorted material is less than the cost of processing, or if there's no market for the material. Do MRFs only sort and recover material that they can sell?
Such a good question. A great example of this is thin film. You know, thin film is something that it doesn't have a current market. It used to. Folks have stopped sorting it. Not really a great current market. But the film actually causes so much mechanical issue. It'll get caught up in machinery and spin around and cause, you know, plants to have to take maintenance. So so in a lot of cases, those materials will be sorted, but to go out to the landfill. And that's just one example. I'm sure there's many others that we could think of where, yes, you'll pull the material out, or it'll just kind of come out naturally at the end because you've positively picked everything else that you can out of it. But they aren't being sold into markets. The markets kind of either don't exist very well right now, or, you know, like you mentioned, the cost of processing is high. The flip side of that, though, to think about is the cost of landfilling. So yes, there's the cost of the sortation, but there's also the cost of the disposal. So a lot of times, even with a thin film, if it were efficient to be able to collect this, you would be able to get rid of it without having to pay the cost of landfilling. So that cost avoidance is the same as making money in some cases. So yeah, I mean, in summary, it depends. That's my favorite answer. It depends on what market you're in, who's around, and how you could get rid of some of those non-valuable materials, more focused on defraying cost than on making money.
Thank you. Let's jump to the Q&A for the next one. This is a question I think you'll probably be used to hearing, but does this eliminate human sorters, or does it help support human sorters?
I'm going to go back to my favorite answer. It depends. And most of the time we see our customers truly cannot find human sorter labor. And so this is meant to be a replacement. But in some cases, what we find is it is truly a QA application where it's getting into a spot that's, tough, or like Moana was mentioning, it's a very particular material to pick. And so it can be very complementary to humans. We also see that it's complementary to other sortation technology. We're not afraid to talk about optical sorters. They are a real part of a MRF. And in a lot of cases, we go behind an optical sorter for QC on what that optical sorter is putting out. So it depends is my favorite answer.
Well, everybody understands that in the recycling world, because it always depends on material stream and other local factors, facility factors. Okay, I think this is a good question. They're all great questions, really. About the AI and how it's constantly learning. Can you describe machine learning or deep learning a little bit better? And is it continuously improving sorting and characterization? And what does it rely on? The operator or AMP Robotics for improvement? That's the other side of that question.
Yeah,
Moana, you are way better to answer this than I am. Yeah.
Yeah. So when we say constantly learning, part of it is the fact that we have over 150 robots out there that we're constantly sampling data sets from. When we receive data from our robots, it comes in as a photograph. We translate that photograph into little parts so that we can train our neural networks with it. And the neural networks are constantly spitting out new versions of itself. It's not all the best. It's not always better than each other, but what we're doing internally is having testing methods and automatic methods to find the best and test and throw those out there. What this does is the robot or the AI is learning from itself and its own mistakes. The humans are constantly curating the data that we're training it with. And the learning algorithm, basically like the actual like meat of the brain itself, is also always being improved upon. And so, even if we weren't receiving data, it would be improving because of the brain mass getting better. Even if we were only receiving data, it would still continue to improve because we're adding more examples that the robot is able to see and work with.
And how can the operator help support that? I guess is a good question too.
So once when we only had about 10 robots out there, we really did have operators fully supporting us, picking out some of the mistakes that it was seeing. We would have these specific recording times where they would run materials that we're making mistakes on. Nowadays, it has become more of a, early adopters are very patient with technology. They want to be a part of its shape. A lot of our newer customers, they just want to make sure it works. And so, it really depends. A customer that does give us feedback, we are always listening to it. We're always using it to be better. But at the same time, we don't require operators to be a interactive part of our development. And so, the door goes both ways, I suppose.
Oh, that makes sense. So great question. What are the barriers to more waste haulers is the question, adopting technologies, but MRF operators as well? What are some of the barriers to that?
That's a really great question. Yeah, Moana, interested in what you've heard as well. I've heard that a lot of it comes down to cost. This is typically a part of a major facility upgrade. It's usually a part of the whole facility upgrade. And so it really comes down to just being able to plan for all of that to go together. And I think there's a little bit of just still it's newer technology. Some folks prefer to wait and see. I think we're at this really cool inflection point. The technology is not as new as it used to be. It's more widespread. And so we are getting a lot more folks saying, yeah, my clients or my neighbors are using it. I'm seeing the results that they're getting. I want that too. And so a lot of it was just being new for a while. But Moana, what else have you heard from customers?
I think that really is the gist of it. I heard from a customer even just last night that everybody needs robots. They want them. Now it's just kind of proving it out and smoothing out their confidence in the technology so that they can dive in. Um, I think something that we do come up against is a comparison against optical sorters, which is known for sorting massive amounts of material at a very high volume. We cannot compete with that. We are scalpels in the industry. We make sure that the quality of what comes out after these robots are very high, where the optical sorters are very known for, dropping in 20 extra percentage of other material. And so, we complement a lot of what exists in MRFs today, and the acceptance of that and like the complementation of the AMP technology to the industry today is really big, pivotal step in the acceptance of it.
A little bit more on the economics of recycling. Suzanne is interested in
Sure.
understanding what are the ways that that AMP is and robots in general are impacting the economics of recycling.
Yeah, awesome question. So I always like to oversimplify things. So I'm going to try to oversimplify it here. It kind of comes down to there's how do you reduce your cost and there's how do you increase your revenue. So when you think about reducing cost, we've got just first and foremost, the easiest ROI to calculate is replacing human sorters, especially if you can't actually find the labor to be on the line. That's kind of easy to just be like, there you go. There's the human sorters. But when you are able to actually pick more, you're picking it faster, you're picking it more efficiently. So the cost per pick is lower compared to status quo. So in doing that, your cost per pick is lower. You're also able to recover more from the stream, which means you're avoiding the cost of landfilling it. So that's kind of the cost part of the equation. But now if we talk about the revenue part of the equation, you're getting more, right? You're picking more, so you're able to actually go sell more as a commodity, and you're able, in most cases, depending on how the MRF is set up to pick, able to command a higher quality bale. So you get a higher revenue associated with that higher quality bale. So kind of how do you replace costs to be more effective, reduce costs so that your cost per pick is getting just a whole bunch lower, but you're also getting better bales out of it and recovering more in general.
Yeah, I also, just as a big picture, long-term thinker for the industry, I always think about just the impact of potentially creating more domestic markets because of the cleanliness of the bales and the materials. So when we have more domestic markets, all costs will go down overall. I know logistics is a big piece of the cost of, being in the market of recycled commodities. So you certainly, from a big picture perspective, I see that as a huge way that robotics can impact the circular economy and making it more cost effective.
Absolutely. Yep.
Yeah. Just my 2 cents, what it's worth.
Your 2 cents is worth about 10 cents. That's awesome.
So, okay, let's go back to the Q&As. We talked about recovery rates a bit. So why don't we talk about equipment breakdown? How is that handled? The real nuts and bolts and the operations of these pieces of equipment, because I know it's multiple.
Yeah, it's a great question. We want our equipment to run at least within the shifts that you have set up, right? Like, because if it's not running during a shift, it's really hard to take down. It's part of the system. So we believe, MRF operators run MRFs, not just our robots. So we have to be able to fit in within the whole MRF and within the maintenance plan there. So our equipment doesn't break down often. When it does, it's usually something that happened, like a big piece of concrete came through and broke an arm, something like that. It's going to happen. But we do have some regular maintenance, and we've got a maintenance schedule, and the stuff that's more frequent, like changing out your cups, excuse me, is meant to be able to be, super quick to do. I've got a dry throat. Moana, anything you want to add there?
We don't suffer breakdowns as much, as it just needs a little bit of TLC. A robot is a very avid worker. It will keep working till all of its arms are broken and it's, just limping along. And so we do really require the human touch to make sure that the rest of it is in operation and ready to go. I think it's really easy to forget because it's so automated that, oh yeah, I should look if the doesn't have any holes in it, or I should make sure that there's nothing jammed into the air pockets. But, so it really does depend on the people that own it, the robot's parents, I guess you could say.
Yeah. So building on that with like those quick, small things that are meant to be, your checkups and your small, quick changes, doing that keeps the robot running. So most of the time that we see breakdowns, it's either something catastrophic, like that concrete block came by, or in fact, the regular routine checks and maintenance wasn't done. Yep.
Okay. The typical residential black bin line, what percentage of material might be pulled out, and does a lot or most stay on the belt or go to the landfill?
Mm-hmm.
So I guess the rejects line,
Oh, that's a political question. Well, as my hobby is to be like a recycling nut. That's kind of how I ended up at AMP. And so really, if the black bin line is the recyclables container, this is Amanda's line, really depends on the person that's putting things into it. Oh, for one thing, a lot of people don't know that if you bag all of your recyclables, a lot of these recycling facilities will just pull that out and throw it right out. And so even if it is 100% PET bottles, very valuable material, they would rather throw it out than to risk the sorter's health down the line. Could be a dead animal, it could be a bunch of trash, they don't know. So this really depends on what people are putting into the black bins, as well as some of the MRFs rules. I know some MRFs do rip those bags open, empty it out, and that it makes sense, but it also makes sense that they don't want to do that. It could be a bag full of diapers. So their goal, though, at the end of the day, is not to send it all to the landfills, because that costs them a lot of money. If they can get as much value out of those materials as possible, that's how they make money. And so it's a win-win for them to try to get as much as possible out of there. And people are looking to buy it. And a lot of these recycling facility owners, they got these really big trucks that they have to pay for. So they want to make sure that it keeps running and getting all that money out.
Thank you. I know you covered this a bit before, but it's obviously a topic of interest, as you said, about optical sorting. So can you just in greater detail explain the difference between optical sorting and AI and robotics technology?
Yeah, I think so. What optical sorting does at the end of the day is it's a very chemical separation. And so it uses a laser to determine the reflected radiation off of the materials that are running through. What this means is that if an item is covered with a polypropylene label, but the bottle itself is a PET bottle, then the optical sorter will identify it as whatever reflects off of that label, which would be polypropylene. And immediately at that point, it will never get that right. What our technology can do is that it's looking in 2D vision like a human. And so it's not only saying, hey, there's a bottle there, it has a giant label on it, and I see a little piece of PET. It's made of PET. And so some of that diversion of, I guess, human thought that we're able to do with the training of our AI really kind of sets us apart from optical sorters. Not sure. I think optical sorters now can also do color and other things, but some of the subtleties that cannot be separated by chemical properties is something where the AI really shines.
Yeah, and adding on to that, optical sorters tend to operate more like 1,000 picks per minute. It's a high speed belt and it's pushing a lot through, which means you tend to have some quality issues. You'll just get, two items next to each other that end up, getting fired on together. So a lot of times we see our Cortex system installed after an optical sorter to do some QC cleanup. And so it's not that one is better than the other. They have totally different applications and, pros and cons to each. You can get a lot through, but hey, it's going to need some cleanup and it can't really get some specifics within it versus, robotics is not going to be as much material pushed through, but you could get very specific about what you need.
Okay. And then finally, I don't want to leave Aaron's question behind here about increasing recovery rates to achieve greater recycling rates. So I'm sure you'd like to address that and talk about what the projected impact is of that.
That's such a great one to end on too, because that's like the we believe everything can be recycled, right? That's why AMP exists. We really believe that we can divert all this stuff away from a landfill. And so like Moana was saying, 34 materials that we can identify. We're getting more and more all the time. And so the projected recovery, it comes down to what are those markets? What is the sortation process that MRFs have? The limitation is no longer the technology and the efficiency around it. That's where this technology is helping make it cost effective to sort everything. We like to joke at AMP that you want to eat the whole buffalo, every part of it. So we believe all of it can get sorted. In theory, perfect recovery is the target.
Yeah, and just to add to that, if you can sort it and make a bale of a pure whatever material, could be toothbrushes, it could be lids, it could be Legos, then you can find somebody that wants to buy it, and once the moment that you sort something and make a pure batch of it, there is somebody that's going to want to use it, and that's what makes trash into treasure for us.
Well, it's really exciting. I think that this is a technical skills learning that gets the creative juices flowing about what's possible in the future, and what we're looking toward happening for our industry. We've experienced volatile commodities markets, and it's important that we start to make those a little bit more secure, less volatile, and more domestic. So really exciting to hear what you guys can do and how you'll get us there. So thank you again for joining us. Thank you everybody for hanging in there. We are, and asking all the questions. I mean, I was like, oh no, we don't have any questions, but then you guys came through. Of course you came through, and had all the great questions that created a wonderful conversation here. And love to hear your feedback. Please feel free to reach out to Amanda, Moana. Yes, there you go. Your LinkedIn's there. Great way to get in touch. We'll be doing our third installment of this in 2 weeks. Oh boy, I should have known that and written that one down. But it is on our Eventbrite. Google it, look in Eventbrite, and you'll see our next installment is with a company that's doing sortation at the container for multifamily dwellings, and a different type of sortation. And so we'll learn about that skill set as well. So thank you again for joining us. We look forward to more of these technical skills training. If you want to learn about robots, I'm sure Amanda and Moana will talk to you about them, and you can dive a little bit deeper. And then please stay tuned. As we talked about, the pillars of WISR is our networking, which we hope to bring back in person next year. But also our leadership skills. We had a great training on imposter syndrome, overcoming imposter syndrome in the spring, and we're going to be following that up again with Demetria Henderson on a follow-up to that, and stepping into our courage, and that will be upcoming in the next month as well. So look out for those notices, join us, and we love having you all here with your questions and your interest and curiosity. Definitely wouldn't be what it is without you guys. So thanks for coming, and we'll see you soon, and happy rest of the week.
Thanks, everyone.
Thank you. Bye.